This episode of the Beyond the Physics podcast is brought to you by you. So if you'd like to support the podcast, please leave a rating and review and consider subscribing at patreon.com/Beyond the Physics. This is Beyond the Physics. Recording now. All right. So, hi everyone. I guess I'll just do a small little intro. Today we're joined with our good friend. Should we call you Simon for this episode?
Yes.
Simon. Okay. Yeah. So our good friend Simon. He's a doctor now. He's got those fancy 2 letters in front of his name.
The DR.
And he's off to go do big and great things. So I think it's great that we were able to pull you in and have a conversation before you go.
Yeah.
And yeah, so that's our intro. Irene's here, of course.
Hello, everyone. It's been a while, so I'm a little rusty in the podcast.
Yeah, we're a bit rusty. But so before we get started, I mean, we briefly told you what we're going to chat about, but I'm curious if there's anything that you wanted to talk about in particular.
Oh, gee, I don't know what to say when put on the spot like that.
That's okay.
In particular,
is there anything that sounds interesting? If not, that's okay.
Gosh, I'm not sure. What is interesting? That might be dependent on the context here. So let's just go into the questions, and then maybe I have a better idea of what I want to talk about.
We'll get you warmed up.
All right. Yeah, let's do that.
Okay, so then let's start with like your origins a bit.
Origins.
Let's start chronologically.
Okay. I am a pretty migrant person, I'd say. So
Migrant.
I was born in South Korea, and then I moved to the States when I was like 5, 6. So I have, very little childhood memories of when I was in Korea. But then afterwards in the States, I've been moving around here and there every 2 years until I ended up in California, which I lived most of my life. And from then on, did my high school undergrad there until I moved into and completed the PhD. That's just how it went from there.
Okay. I didn't know that you left Korea so late, or I thought you. Yeah. Anyways, I didn't realize that you left Korea when you were 5 or 6. So, do you recall where you're from in South Korea, or where you were born?
So South Korea has a lot of jurisdictions, and I think the famous one was Gangnam.
Okay.
And that's what I remember it as, because the hospital's name has that in it. But if I remember correctly, the hospital is no longer in operation. So it's my birthplace has been renovated and no longer exists. But that would be the district. Is that the literal translation? I suppose so. The district of Gangnam. Yeah,
Okay.
In Seoul, South Korea.
Okay.
Yeah.
Okay. Great. Yeah. So I guess I never shared this on the podcast, so I'll say it now. It's like, yeah, I'm half South Korean as well. Like my mom was born there, but she was adopted in the United States because she was born near the Korean War. So there was like a program to like have to adopt Korean kids in the States around that time. So she knows nothing about her background or anything like that.
Right.
So she's totally American, and so I'm not that keyed into that part of my culture, but I'm curious about it.
Yeah.
So it's cool that that you're a little bit more connected to that, and maybe I can learn more. But that's interesting. And then you moved around a lot in the States. Do you remember where you started?
Sure. Spent 2 years in the Chicago area.
Oh, okay.
So I am a little bit of a bias towards Chicago. Childhood memories was like, Field Museum and Shadow Aquarium for anybody who was in downtown Chicago. Probably know what it is. Hope they still have kept the dinosaur zoo. That better not move. And
Dinosaur suit?
Yeah, they have a whole dinosaur, T-Rex dinosaur.
Oh, cool.
The skeleton there. So that's like the front door material. That's the first thing you see once you go in fields. And they have a whole bunch of other neat stuff.
And
So
it's like a
that's-
real skeleton.
Yeah, I would assume so.
Well, I don't
Unless,
know if it was some
like maybe one or two
replicated.
teeth that like that were broke off and like they made it out of cast. But I would assume it's like one of the few rare complete skeletons in field museums or in the world of a T-Rex. So that's the extra cool factor for the 5-year-old me walking in there and just like enjoying, walking into museums and aquariums and stuff like that. Yeah. So I think there was a Korean community in the city of Schaumburg, which was one of the suburbs next to Chicago. So that's where we moved to. And then I think after that, we just went straight to California, and we hopped around here and there. Yeah.
Around California?
Yeah, in California. Like a bit, like 2 years in SoCal and a lot more years in NorCal.
Okay.
I haven't bothered counting the years because it's stupid long.
Like the Bay Area?
Not exactly. Much more closer to the mountains, Sierra Nevada.
Okay.
The famous location is Lake Tahoe, and I'm like, Sacramento is about 2 hours, 3 hours from that area, and I say I'm from the Sacramento area.
Okay. Yeah. Cool. And then I don't know if you want to talk about your high school experience. Is there anything? How did you feel about? I guess let's.
Well, I mean, I was interested to know, like, when did you start getting interested in science, or was that something that, like...
So I was born and bred on the mathematical bread and butter of the Asian tracks. So that was ingrained into me from the start. But I think as a kid, I was really interested in like Legos. So that's probably the starting point, right? Just the toys you get as a kid probably determines what you want to do. And then, pretty solitary life growing as a migrant. It's kind of hard to make friends when you're moving every 2 years.
Yeah.
So you got to find something to do. So the Legos was, just a childhood toy kind of thing. Growing up with that, you just get kind of creative with fitting pieces together, and then it just clicks into like math and physics. I think when I was 12, I also had this weird dream where I could like see like dancing molecules, like not just a dream as in like something I want to do in the future, but dream as you slept and you like dreamed it up.
Yeah.
So I was like, oh, that's really cool, and I want to know how that works, although it's fictional in a dream. So I began to pick up like chemistry and physics to like try to figure out how this imaginary particle in my head would actually work. It is completely imaginary, and about 20 years into physics, I realized, wait a minute, this cannot and should not exist. So that's what got me on the track first. But then the rest of the way was just, it hooked me while I was studying it. So here I am. Yeah.
Wait, so what was this molecule that you saw?
So this was a very weird molecule, but basically you have imagine a spiral, like a corkscrew, and then if you look straight down through the axis, it's a hexagonal pattern.
Okay.
So it's a hexagonal screw.
Okay.
And it is made of hydrogen oxygen molecules. I cannot believe I dreamed this up. I was a nerd when I was 12, I guess. But it was I think the pattern was OHH-OHOHH, right? Which is, for the context, that's impossible because of chemical bonding.
Okay.
But that's what got me into it, like trying to understand how chemical bonds work, and how magnetism works, because magnets, how do they work? And then also how crystals can form from the atoms. For context, I'm studying condensed matter, which is exactly that, and that's how I got here. And I think along the journey to learn about condensed matter, you learn that it's a very beautiful and also an extremely complicated field if you get down to the nitty-gritty. I'm still learning about it. And coming back to the how I got started bit, it was learning about how the molecules and atoms just fit together, that really just got me hooked into the field in general, right? So first it was like I dreamed it up, I wanted to learn how it worked, but then you learn about how other molecules really work, and you just get hooked on it. Yeah. Don't do physics, kids. It'll get you drugged.
Okay. Yeah, but that's interesting. I have a few questions about that. One is, so it sounds like you started down a path of discovery because of this inspiration that was airdropped into your brain as you're sleeping, right?
Right.
Do you have any sense of like where that dream came from? Where you like, how do you, that seems like a very specific thing, a hexagonal OH. Like, how do you even get exposed to that at that age?
Yeah, why are we seeing O's and H's and
I think that's
hexagons?
so. I was 12 to be contextual.
Yeah.
So that I think at that lovely age, you're dropped into like Bill Nye the Science Guy videos,
Okay.
where you learn about atoms and stuff, and molecules are something that you can just rearrange in your head at that point. And then I don't know, what is 12? It's like, is that 6th grade? I can't do math even after all those years of physics.
It's like it's probably around 6 or 7. Probably
Yeah.
6. I don't know.
I'm gonna guess 6. That's probably wrong, but people can skip grades, so I'll get some leeway here. Yeah, so learning about atoms and molecules, and you have all these like graphics whenever they try to teach you, so you basically have a general idea how they connect together in bonds and molecules. Sure, you don't know about like the physics and chemistry, but you know the graphics are enough just to get you started with these like crazy dreams of molecules.
Okay.
Yeah.
So you think it was Bill Nye, like pop science communication?
Science
and
communication,
then
maybe
like,
some like graphical arts.
from like school textbooks or something?
Sure, like even like weird CGI that you can see that you know, if it's sci-fi movies especially, will have just weird graphics of like these molecules that's popping out of nowhere. It's completely fictional again,
Yeah.
but that's probably where it came from.
Okay.
Yeah.
Interesting. But so then that dream I would assume would lead me down chemistry, biology. So then how do you end up in physics?
Right. So biology, I was shockingly good at it, but I got bored. In another life, maybe I would have enjoyed biology. Chemistry, I wasn't so good at. So when I was learning chemistry, it was nice, but I realized if I wanted to study how, more specifically, like I still had that dream when I was in undergrad to study how this molecule worked. But in chemistry, it was more about reactions, how you put together these molecules. And then physics was about, okay, you get into nitty gritty about you connect these atoms together, like what happens to the magnetism, the electrical fields, the physical phenomena surrounding it. That's what I was more interested in. So I just picked up physics in high school, learned about all these cool laws and things, and I was like, okay, this is a tool that if I understand, then it's going to help me a lot more in getting to where I want to be. Right. So chemistry was maybe not in depth enough. Biology seemed like it's such a broad field. It doesn't only touch molecules, it touches a whole bunch of other subjects. So I kind of gravitated away from that. And then physics was like, okay, I can do this. Although I was pretty bad at it. Of all the subjects I ever took, physics was my worst subject.
Okay.
But then you just stick with it because you're curious anyway.
Oh, I can relate to that experience for sure. I'm tempted to share more, but so I was curious then, the dream that you had about this molecule, it sounds like it was pretty important. I guess I'm just wondering if there were some other reasons to go down physics. Like, it sound, because you said just now you realized that like this molecule is impossible, right? Like
that's right.
Like it sounded like it was important in the past, and then at some point you almost forgot it existed or something. So I was wondering if some other motivation came along the way, or you just kind of.
So as I went along in my journey of physics, it changed, it morphed. So no longer is it just hydrogen and oxygen. I'm just thinking of like different ways to attach it to molecules. So the latest scheme that I promise I won't bring into my professional career and just keep it as a side hobby is right now you have a surface. We call that a substrate in physics, which is a kind of a thing you apply on top. It's a used terminology we borrow from biology, I think, from all those like Petri dishes.
Okay.
But a substrate's basically a clean surface you can put whatever you want on top of. So the latest harebrained scheme now is to put on top these like molecules that kind of adheres to the surface using what we call hydrogen bonds. They're like really weak bonding that's in the that's like fake bonds. They don't actually use electrons. I'm digressing here.
That's fine.
But basically, once you adhere these molecules to the surface, then you can have this like quote unquote functional material where by having all of these molecules attaching themselves as a grid on the surface, you can make new properties. And the whole point of these like little molecules was that it's supposed to turn like electrical fields into like stored energy.
Okay.
Right? So one thing I wanted to do when growing up, I was like, hey, Dad, I want to study physics so I can make batteries. Right? So that was a motivation. That was pretty clean. Your parents can get behind it as long as it's not something in arts and science. Well, let me back up. My dad would have let me do anything I want, but this is just what I wanted to do. And yeah, just wanted to make a battery from that little molecule. So right now it has evolved to the point where I'm studying these systems where it's condensed, layered on the surface, and then you can make what we call thin films, and batteries of thin films. So the current direction these days is that it was a hot button topic about 2 to 3 years ago. It's called like solid state batteries, I think. So an application of thin film research is that you can apply these aqueous materials on top of a substrate, and they make these like cool new hip batteries that promise like extended life and higher voltages.
Okay.
Yeah. So that's the direction I'm heading towards now. For personal interests. So we'll see how this goes.
Yeah. So then, just to reconnect that to the question. So the previous scheme was this this OH molecule you dreamed up, and then
Sure.
So would you say that maybe more broadly that these side hobbies, these side projects that you're interested in, is like your primary motivator for studying physics, or like staying with the field, or?
I think so.
Okay.
For me, physics was always a tool,
Yeah.
and less of a beautiful physical phenomena.
Okay.
A tool no different from a wrench that you use to bolt in something. And in that context, I think that also helped me keep sane.
Sure. Yeah.
In terms of motivation. Because if you want to study physics, you better have like an interest in it or a motivation to do it. And in terms of what I think about physics now, it became, now I know the mechanics behind it. It became a lot more beautiful to look at. But still that old side hobby is there. The old motivation is there to learn about, maybe I can make a new battery from what I have learned.
Yeah.
Maybe I can make new devices, not just batteries now, from what I have learned.
Yeah, that sounds like my impression of the culture in like condensed matter experiment particularly. Like, would you say that that's the case of viewing physics as like a tool? Because I think that's perhaps a trap that a lot of theorists fall into, is like taking it too seriously, if that's the right way of phrasing it, of like, they're trying to understand the most fundamental layers of reality or whatever, and they get kind of attached to their theories, and I think viewing physics as a tool is, like you said, I could see how it could save your sanity in some senses, of just seeing like, this is just a tool, this is a wrench I'm using, if it's right, cool, if it's wrong, let's fix the wrench, whatever. I don't know. What's your impression of how you view physics versus like the people around you.
I'm always impressed by those people who have a very romantic view of physics. I think that's a great way to look at it, but that's just not how I view it. I think the theorists that I'm constantly surrounded by, I'll just take it to the condensed matter people, because I only talk about theory with them. Sorry, high energy folks. But I don't understand heads or tails of their talk. I'm sorry. But when I talk with the theory people there, I think they're pursuing a curiosity that they were introduced to while they were studying. And then that curiosity has evolved. Now, whether it's not so practical as to like, okay, this is some tool that I apply to get what I want. It's more like, okay, this is a interesting phenomena that I want to study more.
Yeah.
So I still want to give these theorists some respect. They're better than me in theory, which is a lot to say about physics. And they also have their own motivations, which I would argue is a lot more pure and less greedy. I don't know what to say about that. But I want to say that whether or not you're pursuing physics because you want to apply it to something, or if you're going to study physics for the love of physics and you just want to study nature, I think they're both completely valid views, and I wouldn't put one above the other.
Yeah, okay. Yeah, I mean, I wasn't trying to throw shade at theorists or anything. I'm just observing how you relate to the field.
I wonder, though, in regards to your question about motivation, if it's healthier to have a love of physics, or if it's healthier to have physics is just a tool and I'll just get through this. By the end of the day, I'll have something. I don't know. It probably depends on how well you do on your projects. And that seems like person to person. Is that a sore point? It might be.
Yeah, personally, I think this gets into like the philosophy of science.
Right. Why do you do what you do?
Yeah. Yeah, but like, I think it's what's the word? I guess it's a little arrogant, I think, to think that physics is going to describe everything or something one day. You know, like, I think what we can understand about the universe, I think, it's always going to be incomplete in some form. And striving towards understanding the universe, of course, that's great and that's laudable and respectable. But what I'm talking about is a trap that some people fall into, is that taking their theories so seriously, you know, thinking that this is correct, this is not correct. What am I trying to say here? You think you can help me out? You think you understand what I'm putting down?
I guess you had these experiences where you have a disagreement with other people in terms of what is going on. Unfortunately, I never had that experience. But in a personal point of view, I think in terms of physics not being able to describe everything, I prefer to think physics as a language. So it's no different from the English language. If you look at an object and you describe it in English, you can probably do it with physics. It's just in formulas or numbers. And when you look at it like that, there is no really like, nothing is wrong until proven wrong. Because you could say, oh, this is a imaginary, let's think of like something really simple, a cup with like a handle. You could describe it in English as a blue cup with a handle, and then you could probably have some very complicated topological formulas in physics, and then get one little tiny thing wrong and it looks like a star. But it can be refined, right?
Yeah.
As that's the beauty of science, where even if you're wrong, there's still the next step you can take to make it a little better. And it's a model that you construct based on your observations. Yeah. Although this opinion of like, oh, it doesn't matter if you're wrong, may change if I come across a person I cannot agree with and just gives me grief. So let's put that on the back burner for now. Yeah.
Yeah, I guess maybe to say just a little bit more about what I meant is, I guess I view reality as kind of like statistical, right? I view it as like I'm not sure if you're that familiar with Bayesian statistics. I don't know how much you need.
I'm afraid not.
Okay.
Statistics is a weak point of mine.
Okay. Like going back to the philosophy of science of like, what is it that we can say that we know about the universe? Like the sun rises one day, and it sets, and then you can reasonably expect that the next day it's going to rise and set. And then based upon your models of physics, you could say like, okay, the sun should live this long or whatever. And then so we can reasonably expect the sun to rise and set for however long, but it's always statistically possible, or there's some non-zero probability that that's not going to happen, or there's some non-zero probability that reality is just going to look totally different.
Yeah.
And so I guess it's just I find myself personally more aligning to how you view physics of like, I think it's a tool. I think it's beautiful. I think it's super powerful in terms of describing reality. But you also have to be open-minded enough to like not, buy in completely with what, you're creating, like to always be available to the universe and updating, your models as soon as, up becomes down or whatever.
I can see that's also true. That's interesting. I never really thought about like models that are limited by if it's completely wrong, or it's limited by probability. Like all the air in this room, God forbid, just goes into a tiny corner.
Yeah.
Statistically possible, statistically improbable.
Yeah.
But the statistics is still there.
Yeah.
As like 1 in quintillion. I don't know.
Yeah. And I view that as like a real possibility, as like a real thing that can happen, even though it's almost never happens.
Right. But the beauty of physics is that statistics, the distribution of statistics is built in.
Yeah.
So it always does, you can. Some people don't. You can take account for the probabilities. Right. So that's a different subset of field that I'm not exactly familiar with.
Yeah.
But it's a beautiful field nonetheless. I should be more familiar with it.
No,
but
good.
yeah.
Yeah, I feel like I'm going down a rabbit hole here, and I want to pull it back, but
Okay.
maybe I should just say one more thing. Is it reminds me of the 3-Body Problem. Have you watched that show?
We talked about it before in the past. Sadly, not in this podcast, but I think I have not watched it yet, which is a crime.
Yeah.
But
so I could give that I'll give that a rec. You should check it out. But a spoiler is something that happens towards the beginning of the show. Is there's aliens that kind of fuck with our collider experiments or whatever.
Yes.
And they convince physicists that physics is non-local.
Right.
That the laws of physics that apply in one moment don't apply in another moment. They don't apply in another place. So basically, any laws of physics that you construct are just like for a brief, very specific, location, right? And time. And so then it drives physicists insane, and then they kill themselves because they're like, "What have I been dedicating my whole life to? There is no order to the universe. These theories don't attach to anything."
Yeah, and Einstein will be rolling in his grave. Right.
And so, I don't think that's necessarily the case. It's an assumption that we use in like cosmology and stuff,
right,
that the universe is, I'm forgetting the jargon terms, isomorphic and homogeneous,
right,
that it's the same in every direction and every point in space. And that seems to be true for the most part.
It's like almost saying, if you know exactly where the Big Bang origin was, and then you keep observing it, and you see that the origin moves over time, that will definitely drive somebody crazy.
Yeah. So anyways, this is just to say that, I don't think that that's the case. It seems like a good assumption, as physics seems grounded in that, and to move forward, we have to assume that. But if that was the case, that, physics was non-local or whatever, that it changed with time and space or whatever, and you can't construct a theory of everything or whatever, I'd be like, okay, I'm not that attached to it. I'm just like, it's a tool. Maybe this tool breaks down at that point, and like, whatever. I'm not so attached to the science of understanding everything that it would drive me mad.
But isn't that a problem of not enough information rather than the physics models break down? Like, let's go back to my supposed example of the origin of the universe is moving.
Uh-huh.
If you could track that movement, then you can add it to your model and it'll become better.
Yeah, you could add randomness
But
to the model.
as long as you don't know it, yeah, you can drive a scientist mad.
Maybe.
Yeah.
Maybe.
I think they intervened with the experiments in a way that it was like not consistent at all with the current theory. Like it was completely off.
Right, but now the question
And it was
becomes
off.
why.
It was like inconsistently off too, in like completely different ways. So it seemed completely random.
Right, and then the question becomes why. But that becomes difficult, especially in the context of high energy. It's so statistical. If you just have these error bars, do you know exactly why what went wrong? Oftentimes, I don't know. I guess that depends on the subject, of course. And I'm speaking like I know high energy, but at least at the very least, I know a lot of these astronomy / high energy physics always have these global parameter plots where they're trying to fit a particular parameter like neutrino mass, and they're trying to get it down to a certain uncertainty. And there's always these like plots of like, oh yeah, this and this experiments show this and this results, and they fit along this distribution line.
Yeah.
So we're like 95% confident that it needs to be here somewhere, and then every year that just gets narrower and narrower, and then there's less of a probability. I guess that's where you can fight over it, and then 10 years down the lane you'll be yelling at each other, I told you so. But yeah, at those kind of sciences, it becomes very difficult to know why something is right or why something is wrong when you only look at global statistical fits. So I guess the curiosity I always had was what goes wrong in these models and what can inform us about how physics works instead. Who knows? That seems like a very general view, but I feel like that's how models should be looked at in the first place. Yes, they're not always completely correct, but if you introduce in some other parameter, you can maybe fix it. Unless it's completely horrendously wrong and you just have to go back and look at one of your assumptions. But that's just science in a nutshell. All right.
Yeah. Okay. So I'm going to attempt to pull us out of the rabbit hole.
All right. Please do. It seems like a very dark one, and I'm very good at going into rabbit holes. My advisor would know.
So anyways, let's try and reorient ourselves. Let's go back to the origins, right? Let's see if we can reconstruct.
Let's see if I remember where we stopped off at my origins.
Well, we talked a bit about high school. What about undergrad? What was your experience? Did you major physics the whole time?
Yes. Okay. It was from high school to undergrad to PhD.
So
it
in
was
high
physics
school,
all the way.
Their battery project? Was
So,
in high school when you got interested in that?
I think high school was the time when I was introduced to physics. So, taking all those physics classes that I definitely didn't just get a C on. I definitely did. But still, it got me interested enough to like see how that works. I guess one of the key experiences I had was robotics club. I learned about torque. So they had a weird phenomenon going on where one of the robot's wheels was not turning fast enough, and then we didn't know why a smaller wheel would help. Well, you apply this lovely torque equation, and you realize if the wheel is smaller, then you have more torque. So that's when you're like, oh, physics is actually kind of powerful because it can inform you about how to make something better. So that was one of the reasons why, and that's what I did in high school, by the way. That's why I was like, okay, physics is very powerful, so I'll go ahead and study physics. Got a C. and then continued on in undergrad, where I actually learned all of physics, not just the small little portion of it. Yeah, so in undergrad, what can I say about that? As an undergrad physics student, most of the stuff you do is just learn basic things when your first 2 years. Just, their standard courses of mechanics, electrodynamics, electrostatics, excuse me, statistics and stuff like that. But then, like, in the latter 2 years, you're free to do whatever you want. And I just took a lot of like random electives that I was kind of curious about. Mostly just condensed matter, for sure. What can I say about undergrad? Nothing much. It was just studying. I don't remember doing much outside of that.
Yeah, well, so I'm curious how you felt emotionally during these time periods. Like, for instance, you talked about getting a C in physics in high school.
Not a big deal.
Okay, so
it certainly won't stop anybody from keep doing what you do.
So it didn't bother you?
No, not at all.
Okay, and you didn't have the stereotypical Asian tiger parent breathing down your neck about that?
No. So I think parent-wise, I was very lucky to have my mom and dad who pretty much supported every step along the way. I think contributing factor was my dad, who really was hammered in by his dad about what to do in his life.
Okay.
So he kind of didn't want to pass that on. So he was like, do whatever you want to do. And when I told him physics, he was like, fine.
What if you had told him you wanted to do something like in arts or something?
I don't know. I mean, he was also a child where he wanted to be an artist. And I think he even mentioned to me, like, in his high school, there was this super famous Korean singer / songwriter that I have like a bunch of his albums on. But he, looking back at those ages, he loved to sing. And he was also going to be a guitarist and stuff. I'd imagine my grandfather put a stop to that real quick. So in terms of what my father would have done, who knows? Maybe he would have asked me to like do something more practical, do the Asian dad thing. But at the same time, he was motivated by making sure I have some freedom in my life, because he doesn't want to leave me in a situation where he has a bad job and he hates life or something like that. So it's a hypothetical of what ifs.
And then what about your mom?
My mom was actively encouraging me to be good at math.
Is that euphemism? Is that a polite way?
You could say. I think that's the most polite way I could say it.
Okay.
To be perfectly clear, I was horrendous at math.
Okay.
At 5th grade. And then a couple dozen worksheets and a crying Simon later, I became much better. Yeah. So tough love, necessary love. Unfortunate that I wasn't good to start off with, but who is? Yeah, no.
So you had the tiger mom. A little bit.
I don't know about tiger mom. I like, maybe Hollywood has done such a good job of like making the stereotypical tiger mom who's like unreasonably bad. But
they always dramatize stuff, but
yeah. But the Asian mom, I'd say my mom is very mellow, and and I can thank my lucky stars I have such caring parents. And as proof, I submit that I procrastinate a lot. So they gave me a lot of leeway. Yeah.
Okay. Cool. But yeah, so you went to undergrad in California, right? And I think I remember this, UC Santa Barbara, right?
That's great.
Cool. So then what was your experience like there? I'm vaguely familiar with the school.
UC Santa Barbara has the bragging rights of being one of the most beautiful campuses on the West Coast.
Yeah.
I will die where I stand on this. The only problem is that there's oil in the beaches, but we can take care of that in 20 years in the future. But yeah, it was a lovely time. You get to live on the beach, basically. and then the houses are falling off the cliffs because they're so close to the beach cliffs. Necessary. Well, no, that's a bit distasteful because I actually fell off. But the campus itself, I loved it. The professors were top notch. The classes there were honestly harder compared to my grad school experience. So it was just beaten into my brain by the time I got here.
Wow.
And it was fun. I'll just put it like that. It was fun.
Okay.
Yeah.
I mean, did you, I guess, questions in terms of your experience, like, are there any moments that really pop out of you in your mind?
And for the undergrad stuff, I played more video games than what I'm not comfortable to admit.
Which video games?
Primarily, I think the popular game to play then was Super Smash Brothers Melee. That's when I got into it. Thanks to a bunch of roommates who are up to no good. Shout outs to them if they're listening. But that was the time when I played a lot of games and also just studied physics a lot. Went out to the beach whenever it was just walkable. And yeah, that was just a very mellow undergrad experience, I want to say. Yeah. There was a time when I guess the highlight then would just be the European trip, because I managed to snag a one of those like research experiences where you study abroad, right? So that's a free flight to Ireland, and that was like every weekend you just work for 5 days as an undergrad. You don't do much stuff as an undergrad. You don't understand a lot of what you need to do, but then on the weekends you can go out on these like bus trips and study and just look at all of Ireland, and that was cool as heck. Because it was just a vacation time packaged into what should have been research time. And it was a lovely experience. Yeah. They have, I want to say, Dublin, the best thing I ate there was like a donut shop, which I like really fancy donuts with like the chocolate that fills the donut hole thingies. Like, it was really good. And I would like to add, that's where I got into coffee in the first place. So definitely came away from Ireland with a bunch of things. I hope it's gone now, but I did have a weird Ireland accent for 6 months after I came out of it. I have no doubt that I might have to come out of here with a southern accent as well. It's going to take me another 6 years to change that. So.
Yeah.
Oh my goodness.
Yeah.
I no longer sound like a Californian. I was traumatized when my sister told me that. Oh my goodness.
Yeah. Yeah, I mean, I'm right there with you. But one thing I found myself curious about is you described your undergrad experience as mellow, right? But I wonder how that's even possible. Because
what, you're studying so much that you're losing your mind?
Yeah, because you described your classes as harder than your grad classes.
Oh yeah.
So then how is it that you had a mellow experience, you think?
Let's just say, like, you need something traumatic to happen for me to say it's not a mellow experience.
Okay.
I think.
So you have a high tolerance for stress or something, or what?
Is that what it is?
Well, it's interesting because like I'm hearing you give all your experience of growing up, and like you seem so like stable in a way. Like you're saying it was just mellow. It was like, it seems like there wasn't really emotional disturbance or anything. And I'm thinking about how I grew up, and it's just like I have so much emotional disturbance. Like my whole undergrad was like emotional disturbance.
Yeah.
So I wonder, like, do you
very
experience
sheltered
that, or is it like maybe the psychology is different between obviously me and you? Obviously, there is a difference.
Maybe,
But
but
I just wonder, like, in your experience.
it was a very sheltered experience, I think. Growing up, it's like I'm very family dependent because I'm moving around a lot, so I don't really go out much. Like, i.e., just go out with friends in general. Like, sheltered child also means not too much social life, as sad as it is to say. But that also trying to translate into lifestyle, where you're in high school or undergrad. I don't go out too much. I have friends where I play like go out shopping, play with, and all that stuff. So nothing crazy really happened to me in an undergrad as well. Yeah. I mean, the occasional school shooting's fine. But yeah.
Yeah. Well, for me, the trauma didn't come from the social interactions. The trauma came from the school experiences.
Really? It was that bad? Oh my goodness.
Well, to Irene's point, it's like what I think is it's just how we perceive the events, right? Like how you're talking about, your mom encouraging you to pursue math or whatever to develop your math skills, and then I'm curious what I would have said if I was in your shoes going through the undergrad experience. Like, I don't know if I would describe it as mellow, but I don't know enough details to say.
I don't know. Are you kind of like a B's get degrees kind of person, or is it straight A's every time? Because I was definitely B's average.
Yeah, I wasn't upset with a B, but a lot of times I had to work hard for it.
A's.
Yeah. No. I worked as hard as I could.
Right.
I was very motivated. But sometimes the best I could do is get a B or a C sometimes,
Sure.
So if it got me through to the end, then I was happy.
Okay.
I wouldn't beat myself up over I should get an A or whatever.
Yeah.
'Cause for me, sometimes that's impossible.
Sure. I wasn't really too happy about my GPA. And I always wished it was higher.
What was your GPA?
It was 3.2.
Okay.
Straight B's. But honestly, coming out of there, I had plenty of experience with friends and professors that I have a good time with. I never had these issues where I got into a big fight with anyone. So there was nothing like personal issues I had to deal with. I didn't really have that in my undergrad. Yeah.
Okay.
Yeah. So it was very mellow.
Okay. Well, then
I stand
think
by that.
Let's tease this apart some more. I think I could understand more if we move towards grad school.
Okay.
So
let's make the context here.
Yeah,
right?
because then I have
all hell breaks loose once I get to grad school.
Well, no, because now I have contextual information to know how to relate everything you're saying. So you finish undergrad, you go straight to grad. It sounded like, right?
I had a year.
You took a gap year?
I took a gap year.
Okay, what'd you do in the gap?
I just worked at a sushi shop, and I also did a 3 months in Korea visiting visiting family, and also going to Japan, Taiwan. It was a great trip.
Wow.
It was a solo trip. And I was about to go to Hawaii, but then the volcano exploded, so I skipped that. Yeah. So that was a lovely gap year.
Okay, what'd you think about those places?
Taiwan is stupid hot, but have delicious food. And I almost died walking up that mountain. There's a backyard mountain next to Taipei if you go up north riding a rail. And they have these I don't know why they did this, but there's these steps that are about 1.5 feet tall, and they always put it at the end of the hike, right before you get to the peak. So on those steps, I was just resting every 10 steps I took until I got to the very top. Yeah. And then I also had a similar experience in Korea where there's Jeju Island is on a inactive volcano. And there's also a mountain there that I couldn't climb. So yeah, a lot of experiences of climbing, I think. I feel like I'm digressing a lot here.
No.
But yeah, those trips were very fun. Taipei is where I hung around the most. I just did little day trips here and there, solo trips. And then almost had the beef noodle soup every day. It was lovely stuff with chili oil. I can't even remember the food. I'm sorry. The Taiwan food was so good. So oyster pancakes and all that stuff, and then with soybean milk, which is sweet, surprisingly. And then of course in Korea, I just get treated by the cousins and aunts and uncles to amazing food.
Yeah, like what? Because I'm curious about the culture. I know a little bit, but what's some of the treats that they would give you?
The special one was I was complaining about a stomach ache because I was traveling, and when you travel, you're under stress and stuff.
Yeah.
So when I said that, my uncle took me a fugu place.
Fugu.
Yeah.
Okay. Could you describe it? I don't
Sure,
know if
it's
I-
blowfish.
Oh, okay. Yeah.
Poisonous blowfish.
Right. The one that's
The one that kills you with
Yeah, yeah.
neurotoxins. Yes,
Yep.
that one. So that was delicious.
So you
that's-
had some.
Yeah. It
so
was
they give you
it's
fugu
definitely
when you're sick.
well. It's a
So
real
my
muscle
stomach hurt.
relaxant
Oh.
in
okay.
small doses.
Uh-huh.
Don't take it in large.
Uh-huh.
And then it's supposed to like relieve the muscles in your stomach.
Interesting. Okay.
Yeah, there's a feeling of like cool numbness
Mhm.
after you eat it. It lasts for like 1 hour. So that was fun. Taste wise, I'd say it's just like any other sashimi. Unfortunately, it's not amazing. But it's the experience, I think, that counts. So that's something memorable.
Mhm.
And then I think I had a schnattam of ducks,
Okay.
marinated ducks,
Hmm.
for some odd reason, because they were. I'm not sure if you had any, but they're not like chicken at all.
Mhm.
Completely
Yeah.
different, yeah. And then just like every other Korean seafood imaginable.
Okay. Hmm.
Yeah.
Well,
there's,
cool.
There's a lot of dishes.
Yeah,
I
yeah,
don't
yeah.
think I can name
Yeah,
them
yeah,
all.
yeah, of course. Yeah, thanks for sharing. But so, okay, you took a gap year,
Mhm.
right? And then you did all this traveling. You worked at a sushi shop. I didn't know that. That's interesting. But do you want to talk about your experience at the sushi shop? Was that it?
Sure, that was interesting. So I was the dishwasher in the back. Worked as kind of like a backup chef at times, making the salad and also making the pork cutlets.
Okay. Uh-huh.
Luckily, I didn't have to do any of the sushi
Uh-huh.
because I learned of this horrendous job where you have to make wasabi. If you're curious about how wasabi is made, it's made from a powder, fake powder. It's not real wasabi.
Okay.
But basically what you do is you dump it in a powder form into a bucket, and then you put water in it, and you mush it up so that it becomes the wasabi you know.
Uh-huh.
It's torture.
Because
And
it's
that's
physically
when
exerting, or
No, because it makes you cry.
Okay.
Yeah.
Oh.
It gets into your eyes and mouth, and it's awful. It burns everything. Props to all the cooks that still do this. But that was one thing I didn't want to do, and I didn't do it. That's part of the life of the sushi chef.
Mhm.
I will mention that the perks of being a dishwasher is that you don't have to cut the fish, but you also get free sushi, especially when they invent stuff. So like they're all delicious. I don't know what to say. Yeah. So it was like it was really cool and amazing, the experience. I definitely learned I don't want to be a cook. That's how you know, right? You just work a job for like 9 months and you're like, no, not this. Or 3 months, excuse me. Yeah.
Uh-huh.
Yeah.
Cool. Yeah. But okay, so then you come to grad school,
Mm-hmm.
and then how's that experience when you start?
It's a rough start.
Okay.
So, sheltered child, traumatic experiences I can count on my hand, like not that much. But like first thing that happened when I came here was that I had an unfortunate roommate. I won't say his name. Rest in peace. But he passed away during my roommate's stay. And he wasn't able to keep on. So that was a traumatic experience and a half.
Yeah.
So dealing with that, I had to take a couple of weeks off. And then I came back to study, and I feel like nothing happened. It was just hard. Was very difficult to get over, like someone's death that happened in front of your face. And it was, I think I'm still like in shock over that. So that was part of the epic experience, like welcome to that moment, number one.
Yeah, so
Yeah.
you don't have to share details if you don't want
I
to.
will not, but
Yeah.
that was that really sets the tone for the grad school.
Yeah.
Yeah. And that was just dealing with that, and then it was the grad school does rack it up in terms of like workload, because you're not just a student anymore, right? You also have to teach classes and then research and stuff like that. And when that's, when you get that busy, then it's the workload that kills you, not the difficulty. Yeah. And what was it? It was such a lovely time to be there too, because in my year, surprisingly, we were very social. I think in my first year, the people in my cohort were like all stuffed in the building and going out every weekend. So the first year was like hectic, traumatic, also very busy, yet also very fun. And it was like juggling between all of these experiences that made the first year just like memorable. Yeah. Also, like, you have to deal with a lot of other issues, such as getting over the deaths and also saying goodbyes. And it was, first step into grad school. I'm doing what I want. I'm juggling all these experiences. And it was, it was a lot. But, it's not because of the physics part. It's because of life comes in and then, like, hits you on the head sometimes. Yeah. But then, oh my gosh, I don't know how to say this. I'm not sure if this was experience with you, but after you get into the groove, it's a blur. Like, from the year 2 to year graduation, it's like you do the same thing over and over again until you're out. And I don't remember much of it now. It's like all crossed out in my head. Yeah.
You have to teach a lot throughout the, let's say, year 2.
I
So
was-
year 1 and 2.
Yeah, I was very lucky with my advisor. Best advisor, bar none. And my advisor was able to get me into a research assistant in year 3. So that meant after 2.5 years of teaching, I could get off of the teaching assistantship and then into the research assistantship, where it was iffy for a while, but I stayed as a research assistant for about the rest of the years. So lucky, very lucky. I'm sad to say I basically used up all of her funds. So sorry, next student who's coming in line. Hopefully you get a different grant. But it was a good experience in terms of my research years.
Nice.
Yeah.
Let me remind you of some of the major milestones, because there's a lot that you have to pass in the PhD.
Oh no, yes.
How was your experience with the quals?
I lost my mind. There was a time when I was studying for it and I was next to my krypton fluoride. Krypton?
Okay, yeah.
That's a real element, right?
Like a sample you're making?
Yeah, fluoride is poisonous, and then I got dizzy from studying, and I thought it was from the laser. Had to call my advisor. Turns out it was completely fine. It was just my head. But that was the signs of like the strands are coming loose for sure. Yeah, no. I think chatting with all my friends then, it was like everybody was collectively losing their minds. So it was somewhat okay, but it definitely wasn't at the same time. Luckily, I'm happy this happened, was that the year after.
Going back up. All right, sorry about that, folks. If I cut it, Sage went crazy for half a second. There, we got a package delivery. So where we left off was talking about the quals. Let me see. Do you remember where you were, or should I try and reflect?
I think it was just losing my mind over the quals, right?
Yeah.
I guess this is like just, it kind of feels like a review of FSU's quals experience. And this is like the complaint department, but they already changed it, so I can't really complain it to them. But the year after I passed, they changed the quals to make it easier, right? So that was the big deal that people like and don't like. But like, it was surprisingly difficult. It shouldn't be, because the questions you see are like undergrad stuff.
Well, they're
supposed
supposed
to be.
Yeah.
Well, until you get to like the special questions.
Well, I
when it's
mean,
custom made.
I know there's some of them that they pull straight out that they use in the grad classes,
Yeah.
right?
Yeah.
Like yeah. Anyways.
But I found that most of the stuff I did learn about in undergrad.
Okay. Mm-hmm.
Yeah.
Well,
It's just
you did have a good preparation, you said, right?
yeah, but it was still hard. My goodness. Either that or I'm not very good at physics in general still. But I have to admit that it wasn't my intellect, but rather I just memorized everything.
Yeah.
Yeah, that's the only way you could do it in a specific amount of time.
Mm-hmm.
They give you 4 hours, but that's just not enough to figure everything out.
Yeah.
Yeah. Yeah, and then it doesn't help that it's so memory based because a lot of the questions, again, this is the complaint. A lot of the questions require you to remember a very specific formula or very specific rule. Otherwise, you can't solve it.
Mm-hmm.
So I think that's where I was like losing my mind because my memory sucks.
Mm-hmm.
Yeah.
Mm-hmm.
But that's just physics in general. Yeah, the quals sucked. After you pass, I don't think you get a break. They just put you on the grind really quick for the research, right? I'm not sure what's the experience for you, but for me, it was like my advisor was like, okay, you passed the quals. Congrats. We'll throw a party. And I need you to do your prospectus in 3 months.
Yeah.
I'm like, oh, okay. Yeah. Did it. But it was like, it was a special case in my part because most people before me didn't do their prospectus until the last year.
Yeah, yeah.
But they cracked down on it in my year.
Yeah.
And it was like, oh, okay. So doing the prospectus, making it, 10-page preparation for the prospectus and just doing it, getting it done, and then you're on the grind.
Yeah. So I'll share my experience, but one thing I'm curious about is how many attempts did it take you to pass?
Oh, geez.
Because I think they give you 4
at the time. It was the third attempt.
Okay.
Right, because it was summer, winter, summer again. That's when I passed.
Okay.
Yeah.
Yeah. So, yeah, my experience with the quals was an insane journey. Very atypical. Took me years.
Oh, no.
Because there was a lot of extenuating circumstances and stuff like that I ended up taking advantage of or whatever. Like, because I was part of the master's program. And then
they give you extra tries.
Yeah, and then I came in at like not when all the other PhD students come in, so they said you don't have to take it because it's kind of out of order or whatever. So I don't remember whether I took it or not. And then COVID happened, and they let people opt out. And so then by the time I ended up taking it, they had already changed it. So I took it. I took it once before they changed it, and then they changed it in the middle.
Good.
And then I took it after it changed. So I got to do both multiple times. Anyways, so this thing dragged on forever because of all of that stuff.
Yeah.
And yeah, I was convinced that I was not going to pass. I was convinced that I was going to get kicked out because
that's part of the stress for sure.
Yeah, because a lot of my close friends, like you may know Juan Macy, and
I hate his story of like how he got kicked out. Like that's not a happy ending. Yeah,
he works in a similar field as you, right? And
yeah.
And Terrence Fisher, who's good friends with him. Anyways, so a lot of people I personally knew and were close to got kicked out for it. So driving you mad is like definitely one way to put it.
I think it's a stress that gets you, right? The stress of like, if I don't pass this, then there's consequences I don't even dare think about.
Yeah. And so did those types of thoughts occur to you, or like how was your experience?
Oh yes, that's why I was losing my mind for sure. Like when I'm talking with friends about like, oh no, what do I do when we don't pass? And like I'm so stressed out. The stress really does rack it up as you're getting closer and closer.
Yeah.
And to be fair, a lot of people didn't know about the quals when they got to FSU.
Yeah.
I did, and I studied like my entire gap year, but I still didn't pass.
Yeah.
So I was like, oh no, what do I do?
Yeah. Yeah, most people, hardly anyone passes the first time. I think the vast majority.
Doesn't pass. They should pass because that's what it was built for.
That's
like
how
they
it's
expect,
supposed to be. Yeah.
Like coming into the open house bit, they're telling you like, oh, please pass on your first try. I'm like, sure, I'll study. I still don't pass. So it's
but almost no one passed. You know?
Exactly. Yeah.
Yeah, almost everyone passed the third or the fourth try.
Exactly.
So, anyways, yeah, that whole thing is a mess.
Good thing they made it easier.
Yeah.
So it's less of a memory test.
Yeah, they did make it easier, but they, in my experience, it was a little easier, but they still kept a lot of the
Questions.
It's like half of them were the same as the previous test,
They usually do that.
and then half of them were like newer and in general, like
Custom.
a little bit easier. So overall, it's probably better, but
No, I do not remember those experiences kindly.
And then you talked about your prospectus. So just to recap the audience, to become a PhD candidate,
You have to announce.
most schools have a oral and a written exam. So our oral exam is a prospectus where you present the idea for your PhD, right?
Yeah, to be clear, this is only for the American PhD.
Yeah, I'm not so sure how it works for the other
It's
PhDs.
very different.
Yeah. But so you got your prospectus in 10 pages. That's actually pretty good. Mine's
So many people usually make it like 30 to 50 pages.
Yeah.
But then my advisor was like, no, we're cracking down on the limits now. So I'm
Uh-huh.
like, I'm okay with this. So
Yeah.
I had an excuse to work less, so I'm taking it. So I was just 10 pages submitted to the audience, and then it was done.
Yeah, that's good.
Yeah.
I mean, my advisor told me, oh, yeah, they say it should be 6 pages. I'm like, okay. So then I start writing, and 6 pages happens like that. And I'm like, okay. And then
It's like, wait a minute, all my figures make 6 pages.
yeah.
Yeah.
And then he's like, oh, yeah, and you should talk about this, this, and this. And then I'm like,
And it adds
okay.
up.
And I'm like, that's impossible. And then he's like, yeah, that's probably impossible. So just keep going. So yeah, anyways. But so the prospectus, my experience wasn't as short of some drama, interpersonal relation stuff. The actual writing the document itself wasn't as nearly as traumatic as the quals.
No.
That was your experience.
It should
as well.
not be.
Yeah.
I hope it wasn't. It was way easier to write the prospectus than study for the quals.
Yeah.
Yeah, that was pages and pages and pages and pages of work.
Yeah. Okay.
That I think I don't have the old notes that I kept anymore.
Mm-hmm.
That's a good thing, I guess. But yeah. Oh, but going back to like if it was more stressful in undergrad compared to the quals, was it? I guess I was stressed out in undergrad if I compare it like that. It was just as bad as my undergrad studying for the finals. Like the stress, isn't it the same though? Because it's like the stress of studying for your finals and the stress of studying for your quals, it's comparable, except for the fact
like it has
more consequences.
Yeah.
Yeah. Because like in undergrad, if you fail a class, you're often given, you can just retake the class, or you can drop before the consequences come.
Right.
With the quals, it's like you have a deadline, you have to pass it in this deadline, and if you don't, see you later.
Right.
So it just feels like more serious, I guess.
Yeah, I guess part of my thinking that it was just as bad as undergrad is because it's in hindsight now.
Yeah.
Just as like any other stressful experience. We'll get into the dissertation later. But yeah.
Yeah, when you're in the class, it feels terrible, right?
It feels awful.
Because it's the most important thing that's happening at the moment,
right?
You wouldn't.
You definitely don't look forward to the all-nighters you have to spend.
Mm-hmm.
That's true.
Well, I have a question in terms of the stress, like these moments that you have of stress and like the traumatic moments too. Like, what's your experience of that, and like how do you cope with it? What would you say is your coping?
Coping mechanism is more procrastination. I don't recommend this, but I think it's very human. Basically, you put it off until the very end, and then you have to pull the all-nighter. I'm pretty sure most people know what this is like. Which just adds to the stress, and then until I have to do it, I do it. I think that's something I want to work on, going into like the professional side for sure. And I do have a way to, start earlier and be better about it. That's not exactly a coping mechanism, is it? What is a coping mechanism?
Well, also, like, how do you deal with those feelings of stress that you say you have? So you mean like you push them to the side and you're like, okay, I'll do something else when you say you procrastinate?
Exactly, yeah. And
So
then
what happens to those feelings?
I guess it just stays there until it's finished.
How did
it's
they
funny.
go away?
When
They
you
just
finish it?
disappear?
Yeah, how does it not distract? Like when you set them to the side, how do you stop them from bubbling up and distracting you?
Oh, like how do I not have a panic attack?
Yeah, sure, something like that. How do you?
Gee,
They just don't.
surely not. Hold on. I do procrastinate via YouTube and video games. There it is. You need an outlet, right?
Mm-hmm.
Like somewhere to store your stress away for a little bit and then get back into it.
Mm-hmm.
So I am a fan of, like, we mentioned Super Smash Bros. Melees earlier. So video games
Uh-huh.
is a part of my life, and also just surfing the web, as
Mhm.
any other internet sleuth would just be like, take time away to just distract yourself and then come back to your work.
Mm-hmm.
Which, yeah, I am human, so I will procrastinate like crazy, like no tomorrow. But at the end of the day, if there's a job that needs to be done, then even if it takes all night, I should probably finish it.
Mhm.
So there is a cutoff bottom line that
Mhm.
at the very least I have to just keep up with the work.
Mm-hmm.
We'll see if that can change in the future. But yeah,
Mm-hmm.
a good I don't know, what is a good emotional response or healthy response to like dealing with stress in PhDs? Is that taking a trip outside, I suppose, weekend trips and stuff like that?
Yeah, in
Yeah.
my experience, well, the thing I've come to learn is taking care of your body, right? So that means like when I'm stuck in the shit, then
Take a walk.
yeah,
Yeah.
and grounding yourself, getting inside of your body. So exercising, finding an outlet is fine. Finding an outlet's great. Whether that's video games or your hobby or whatever.
Mm-hmm.
Reconnecting with who you are, and I think perspective is helpful. Recontextualizing, like trying to get that perspective on, like, say you're in the quals or whatever, and like
Yeah.
visualizing, like, okay, it doesn't work out. Does that, like, it can feel like it's going to be the end of the world.
It really did.
Yeah, it feels like my life is going to be over or whatever. But if you stop to think about it more clear-headedly, or try to be realistic about it, your life's going to go on. And there's going to be a path forward, and just have confidence that you have the tools and the capability to figure it out.
It's true. And I think walking is also a huge part of how I deal with stress as well.
Mm-hmm.
So whenever I just feel like it's too much, I get up, I walk around, and yeah,
Like walk around the office, or like what do you?
Anywhere,
Okay.
anything, anytime. So if it's raining, sun shines, or whatever, I'll walk around in my office, pace back and forth. That definitely is like my stress response for sure. Just walking around here and there.
Yeah, that's good.
Yeah. Yeah, that's really it. Like if it's stressful, then walk around, procrastinate a bit, then get back into it, and just try to do the best as you can.
Mm-hmm.
I think I'm definitely a type of person who leaves it half finished if I can't do it.
Uh-huh.
Like if what happens,
Uh-huh.
and then just do what you can from there. Yeah.
Yeah. So, yeah, I have a certain impression of you, and you could tell me whether you think it's accurate. Is that, like I mentioned earlier, it seems like you have a high tolerance for anxiety, for stress. Like,
Is that true?
like these things come up and they affect you, it sounds like, but
Yeah.
it doesn't affect you as much as I would expect it to.
Maybe.
And yeah, so then the possibilities in my head were either you have a high tolerance, or you're really good at like not presenting that to the world. Like what you're experiencing internally is like intense, and you're just good at not like showing that.
You might be onto something. I have to go to the dentist for all these cracked teeth lines
Okay.
because I chew my teeth at night.
Oh, bruxism? Like, you grind your teeth?
Exactly. So maybe that's the stress
That's
response.
where all the stress comes out.
Exactly.
At night.
Yeah.
When you're unconscious, the stress will just break your teeth.
beware the quiet man or something like that because they bottle up too much. No. It's I think it's my philosophy would be just to have things come and have things go. What happens happens, and if I can't do it, then I can't do it. I'll do it later, or I'll deal with the consequences.
Mm-hmm.
Yeah. So I don't know. It's perhaps if there comes a time where it's like a life-changing event, and I have to change my ways. I'll have to think about, like, I have to deal with stress a little bit more differently.
Mm-hmm.
Especially coming to grad school, though. Grad school is really, for me, it felt like just a bunch of hoops you have to jump through, one after the other.
Yeah.
And, you have 18 years of your life to go through that experience all the way from elementary school to as a student to your grad school life. So you probably, by the time you hit grad school, you already have a pattern for the better or for the worse. Yeah.
It's not the better for me. Let's say that.
I think everybody in grad school is surprisingly similar, though, in terms of like getting things done still. Okay. Like there, yes, we all had different times when we finished the quals. But after that, when we're doing your research and doing your papers and stuff, we're quite similar in terms of like, okay, I'll do my research for the day, I'll do my papers, I'll procrastinate, do some video games, whatever. Because we're all students, and that's just baked into what we do. And culturally in Florida State, I think it's a lot slower.
What do you mean?
Compared to California, at least when I'm making apples to apples comparisons.
Yeah.
It's the pace is slower at what people do. The attitude is much more mellow.
Yeah.
You mean like in the school, like in terms of the graduate studies, or you mean like in general, like the environment?
Yeah, I think it also applies in the general environment as well. Making that it's always the Florida versus California thing, right? But California is high pace on the gas, and in Florida it's like laid back, and you do what you do, take your breaks, go away, then come back later. So that also affected like how I worked, definitely. Losing my track here.
Yeah, if there's not much more to share there, we could go back to the timeline. So past the prospectus, and then it's the grind years, right, of doing research.
Right.
Is there anything you want to share from that experience?
I guess in research-wise, that was the first research experience. Like, I had some in undergrad for my Irish research, but it wasn't really too much in depth.
Yeah, was that in condensed matter?
It wasn't also in condensed matter.
Yep.
Yeah, and then it was just on substrates. It was like spectroscopy and substrates characterization. Very bog standard stuff. So I really didn't know about research until I got into grad school. And then in the grad school years, I was, taught by the older students on the ropes of what to do. And then it was just like one research trip after the other of like constantly being busy and went on to the next project. If there's one complaint I had about my research, and my advisor, if she hears this wasn't too bad of a complaint, was that I was always on the gas without any time to like take a step back and analyze something. Like there was a bunch of failed projects in my grad school experiences, such as I was especially bad with computer simulations.
Okay.
That was a bust, which took up a lot of my time. And there was also like I always had to travel a lot for what I do, because you have to go to other laboratories with highly specialized equipment.
Yeah.
So I'm always on flights every 3 to 4 months,
Mm-hmm.
and coming back and analyzing data I never knew about.
Yeah.
So the grind is always very tough.
Yeah.
Yeah. And you always wish there was more time to analyze something before you're sent off and shipped out to another experiment you have to do.
Mm.
So that was 4 years flashed by real fast.
Hmm.
And then you have to do your dissertation. My goodness. Yeah, no, I was not ready for that. But you have to finish at some point. I think one thing I can add about that research experience was whenever I got the data and came back and I analyzed it, something else interesting popped up, and I squirreled away from analyzing it and just went to the next project, which was part of the problem with my research. I couldn't really get a lot of papers out because all the data was just squirreled away in a corner, and we never got it into the paper format because we didn't really sit down to the end and finish it.
Uh-huh.
So, which is why I'm currently writing papers and rushing and all that stuff.
Mm-hmm.
So, in terms of personal experience with my research, it was a bit of a mess of organization. I need to just sit down, finish one, go on to the next step, and then move on like that.
Mm-hmm.
But I'm not sure if any group does that. I'll have to ask around and see. Yeah.
Well, I'm trying to do that, but
Finishing off papers and here and there. Yeah.
that sounds like somewhere where maybe your advisor could have stepped in, right, and helped provide that organizational structure. Or do you think that's your responsibility?
It's a little bit of both, ain't it?
Sure.
Yeah. It's like, okay, how fast can I do this? If I keep procrastinating, there's nothing my advisor could do. And also in terms of, is the data complete? If the data isn't complete, then you can't really make a paper out of it, because they want a story, not a question. Yeah. It's a part of my speed and the part of we should have sat down and really just finished it in hindsight. Yeah. Who knows? There's always a million ways where it could have gone better, but at the end of the day, you do your PhD, you finish, it's a good feeling.
Bees get degrees, man.
Indeed. That could have been the motto of my life.
So okay. So then it sounds like we're getting near the end. The dissertation, that's very recent history.
Yeah, still fresh.
Yeah, I mean, I definitely want to know more about that process for my own personal reasons.
Dissertation.
So
that's going to be soon for me.
I hope it's not the case for you, but coming into the dissertation for me, I didn't have enough papers. That's a huge problem, because now you're not organized and you have to do all your analysis in the span of 6 months. That's not what you want to do. What you want to do is have a couple papers already and just copy paste everything. That's what my roommate has done. Yeah. And he got it done in like 3 months. Much less traumatic experience. What I had to do instead was, because all this data wasn't analyzed, was I'd spent the first 3 months just analyzing all the data, and I planned to graduate in spring. It didn't happen. Because it was the data, I was still doing data analysis. So by the time it hit like April, I just barely had a chapter describing just the basics of how I grew these thin films. Well, I'll just be much more general here. I could only describe like one chapter of how I grow crystals. And then I had like 5 more chapters left. And then what happened next was just a whole bunch of day in, day out analyzing, losing my mind, all-nighters of like compiling data and chapters together, where by the end of my PhD experience, I was still rushing to complete it. And my committee members had like a half-complete thesis they could read, and they were asking for like, hey, where's the finished thesis? This isn't complete. But in the defense, the dissertation process was such that it was almost rushed at the end, and then I had to drag it to the last minute to finish it. But you know, It's a pretty lengthy process. They always tell you to start early, or at least do a certain section that you can complete. But like, it's hard to do because you're so busy with everything else. Yeah. So maybe the wisest of PhD students will take some time to just write out a section 6 months before of what they already done, and then they'll move on to like other projects they have to like finish off, and then by the time that dissertation comes around, then you have a half complete thesis. At least you have something started, ready to go. Yeah, I couldn't do that because I didn't have enough papers, right? So coming back to the organization was just rushing all at the end. And then now what I'm doing is that I'm compiling. I'm doing it backwards. I finished my dissertation. Now all the data is ready. Now I'm transferring, copy pasting that into papers out the door and all that stuff. So it's stressful. It's very stressful. Not recommended how I did it. There's better ways to do it. Yeah. I guess one more recommendation I'll put down for any of the future grad students was that if you have techniques or experiment, if you're especially even experimental procedures, just write it all down. Save yourself the trouble of doing like hours and hours of work when you have 2 weeks left. Start that latex document right away, and that's all that I could say about that, because it's just a story of, gosh, I wish I started earlier.
How long did your dissertation end up being, your thesis?
About 130 pages, but it should have been longer.
Should have been longer.
Should have been, yeah. Because that was a half-finished story, and that we need a little bit more data to finish that. Yeah.
Oh, okay.
It's pretty lengthy. Honestly, the problem was that I did too much. Too many different measurements, and you have to compile them all together.
Yeah.
And if I had done one experiment less, then it would have been a much cleaner thesis for sure. Yeah. I guess I could talk a little bit about research-wise. I'm not sure how descriptive I can be in the general audience sense.
As much as you want to talk about.
Yeah. So I did a total of 5 different experiments. One is like crystal growth. So this is the field where you have to like put powders with sintered powders into a hot crucible or some kind of like hot medium to make it liquid, and then you cool it back down into a solid state, which crystallizes, and then that's how you make huge crystals. And it's very similar for when you grow a thin film. You just kind of paste it on the surface, and that makes a thin film, and you cool it down. This second thing was a lot of scattering measurements. Scattering is the act of when you collide particles, and then they have different trajectories, and the kinematics of that tells you a little bit about physics. So ARPES is a type of scattering, is electron scattering. Yeah. There's also a experiment where you go to nuclear reactors and you can scatter neutrons, which are non-magnetic. Well, hold on. They are magnetic, and that's why they can tell you magnetic structural information. So I did that experiment. I think the biggest one in America at the moment is definitely Oak Ridge National Lab. And that's an experimental facility where they do a lot of neutron scattering experiments. So that's part 2. Part 3, I think, was like X-ray spectroscopy, which requires you to go to these massive buildings shaped in a ring called the synchrotron, which is like the yesteryears of what CERN does on a much smaller scale than CERN. But basically they spit out these highly intense beams of X-rays that you can use for spectroscopy. They can tell you a lot of material information. And a lot of people use them for, especially in the condensed matter field, for chemical information and structural information. So that's number 3. Number 4, which I regret doing, was density functional theory. This is the simulation part.
Okay.
And that was just a mess. I don't know how to do simulations, and I learned the hard way that you probably should leave an expert. That's just a project that you should leave to another group or another physics student. And then number 5 was IR spectroscopy, so another spectroscopy measurement. We use infrared light. So those are the big 5 for my thesis, and just compiling them into the thesis was just a nightmare and a half. Yeah.
So those are all different techniques. What was it all for the same type of material?
Indeed.
Yeah. Okay.
And the material of can I say that? Which material I worked on?
I don't know.
Oh, okay.
It's a secret for you then.
It's certainly not a secret.
Okay,
And I
then.
wish there was more people studying this material. So just bring the word out.
Okay.
So it's a cobalt vanadate spinel. So cobalt vanadate is the chemical makeup, and the spinel is the geminology term, which kind of describes the structure of the material. So a lot of these terminologies come from old jewelry. When you say spinel, it's typically a jewel. And it's a magnetic material that has all these cool physics of magnetic frustration, which is a topic all in its own, and orbital ordering, which is also a subfield. And it was a singular material that has a lot of physics that you can just grab out of it. So my entire PhD was one material and a whole bunch of different techniques. And that's the hard bit. Yeah,
that's cool, man.
So what made you interested in focusing on that material?
Well, I think it was more about just trying to grab some kind of story out of this material. As a bulk material, that's a fancy word for if it's grown as a crystal compared to when you paste it on a substrate as a thin film. The properties of this material can change. And the thing we found with this crystal was that you can alter the magnetism just because it's adhered to some kind of surface. So that was a cool property, and we wanted to figure out why. 5 measurements and a failed simulation later, we still don't know. So that's just unfortunate that we couldn't get the complete story out of it. But we get closer. What we found out after a bunch of experiments was the structure is tied to how the magnetism orders, or where the magnetism points towards. And we call that a property called magnetic anisotropy, if it's directional. And with the structural perturbation or structural changes because you grew it as a thin film, it can heavily affect how the magnetism works. And I think what we found was more interesting, that not only does it change its magnetic anisotropy, it can also induce a new phase of magnetism. And by phases, I mean how the spins, the magnetic moments, which are individual magnetic sites in the crystal, can order with respect to its nearest neighbor, whether it's up, down, or down, up. The structure is heavily tied to these couplings. And by perturbing it, by growing it on top of a thin film, you can see a new exotic field of magnetism that was never really explored before. So, which is why you need a whole plethora of different kind of experiments to characterize what's going on, like what the local, the global, the magnetism, the structure, the dielectric properties, because that's apparently a different thing. And yeah, so much more to explore just to get a microscopic idea of what is behind the physical properties of what I'm observing. Yeah. So that's why because there's just so much to explore, I got stuck on this singular material.
Yeah.
Yeah.
So, like, what in the end do you see is an application for the material? If that's even what you're looking.
I think the extraction of information here is how can we relate structure to spin. So spin is a magnetic property in crystals where every electron, we're talking about electrons for crystals in this case, every electron has a magnetic moment. And the whole idea with future devices is that you can reduce the amount of energy you use. Is if instead of electrical currents to run a transistor, you can use spins instead. So if you want to try to control spins, a great way to do that is knowing how spins tie with some kind of property, in this case, structure. So a application we can have with terms of the research I have done in coupling structure with spin is that in the future you can have devices where you perturb the material by growing as a thin film. Or from the research that I did, there's some other property you can perturb such that you can control exactly how these spins orient themselves or how they stay stagnant in a device that uses spin in the future. So it's not a direct application for this particular material, but the information we extract of how these spins can couple to the structure, I'm going to be a little bit more specific, structure, orbital mechanics, and also even electrical fields can all tie together. It's a very important understanding for building a model that we can make these devices off of. Yeah. Unfortunately, and this is a question I get asked by most of the general audiences of what can we do with this material? The applications for this materials are severely limited, primarily by the fact that a lot of the interesting physics happen at cryogenic temperatures, which require super expensive helium that are not economically or practically possible. So a lot of the physics these days where it uses cryogenics assume that the models you build from the research will have applications to real world devices later, much later down the road, whether that's due to cryogenics getting cheaper or we just discovered a room temperature version that can apply the similar physics off of. So it's a bit of a leap of faith, but I think the value of the research is still there. If you can make a general model, maybe it'll apply. Who knows?
Yeah, that's interesting, man.
It is really interesting. Well explained. Thank you.
I wonder if it's too general, but
no, it was great. I mean, just one thing I don't know if I've shared with you is that, I have a bit of experience in condensed matter experiment. That's what I did my undergrad research in.
Right.
And I think Irene as well, right? So
I had a summer of a little bit of condensed matter.
Yeah, so we know a little bit about what you're talking about. I studied graphene and then this other material, sodium iodate, which was supposed to be interesting for topological insulation or something.
Yes, everything is topological.
Yep. So I was interested in thin films and 2D and all that.
Very cool. Okay.
All that jazz. So yeah. So that's super interesting. But so you name dropped the lab. I won't repeat it, but
oh, that's not something I wanted to.
No, that's okay. No, I'm not saying it's bad.
Okay.
I just bring it up because that's something I want to talk about. Is the future. So now that
that lab.
Yes. Yeah. So now that you're a doctor, Simon,
yes.
How are you feeling about your next steps?
So the next steps will be. Can I say it? Should I say it? Yes. No.
Only you can answer that, I think.
Okay, I see. The next steps will be at the postdoc, and it'll be at the Oak Ridge National Lab. And I'll be working again in the field of thin films, and hopefully to continue my research in the coupling between magnetism and structures.
Okay, but not the same material.
Not the same material.
Okay.
This time with a topological twist.
Okay, yeah.
Right, so everything's topological,
Topological
including
twist.
the field of studies these days.
Uh-huh.
So it'll be new in an exciting field that I'm not completely familiar with. But the applications for thin films are still there. This time what we're going to do is another branch where we're trying to do a field of spintronics, which is coupling spin with electronic materials to make it more energy efficient or faster.
Yeah.
And a lot of these technologies require like high intense research into how to make these materials, which is what my next field would specialize in. It's just growth, characterization, and quality control, how to make these materials cleaner.
Yeah.
So that's a lot of the focus that's going to be in my postdocs. I will say, however, as a postdoc, we have a lot of freedom. We want to study. So I need to go in there with a better idea of exactly what material I want to study. But that comes, I think, with the intuition you build up within the first couple of months being there about like, oh, I can do this, but I definitely can't do that. Yeah. So it'll be uncertain, but exciting times ahead.
Okay.
Oh, so you have to come in and you kind of make your own project of what material you want to look at?
Kind of. You get a better understanding of what you want to study as you look at data sets and research of materials. They kind of first start you off on just to learn how all the equipment works.
Okay.
And then I think as you get more and more into it, you suddenly pick up on this project that you want to deeply invest into, and then you just go for it. Luckily, Oak Ridge has the resources to make a lot of the moonshots happen, the crazier ideas happen. So I have an unprecedented amount of freedom in what I choose to study. And I'm still like going over the different candidates at the moment. It seems very exciting, for sure. There's a lot of new physics ahead to be discovered, especially in terms of like magnetism and coupling magnetism with electronics. So hopefully within the next couple, it's always 50 years ahead in the future, but within the next couple of years, we might actually see a lot of these spintronics come to action.
Yeah.
And maybe one day the computer chips won't take 300 watts, 500 watts out of your electricity bills. Who knows?
Yeah, that would be great.
That would be great.
We need that in high energy because the amount of energy we use to be doing our crazy calculations.
Gigawatts, right?
Yeah.
Yeah, no, the Mag Lab's very similar. So I think the energy costs of running a computer these days are like astronomically high. Yeah. So that's a very hot topic.
Yeah.
I do have a few questions about just the process in general, like getting the postdoc. First off, like I know there's different types of postdocs, I think, right? Like some if you're gonna go into teaching, like academia type of
That's
postdocs.
right.
And then maybe research type postdocs or something.
So for the teaching postdocs, I think teaching you can go almost directly into a professorship.
Okay.
Straight out of a PhD. At least I know a couple of people who have done that.
Okay.
But as I never went through the experience, I can't really comment on the details.
Yeah.
For a national lab, this is very similar to a regular job interview process at a much more traditional company. So for national labs, you'll have to go through this lengthy process where you give out the recommendation letters, apply for this position online, talk with your boss, future boss, and then go through the interview process where there's like 8 or 9 groups of people who stay with you for 8 hours.
Wow.
And you're just talking nonstop until your voice is hoarse. And hopefully by the end of it, you'll come out with knowing whether you have a strong position in that job or not. And they'll let you know within like a month or 2 after your interview if you got the job. In terms of competitiveness, that depends on the university or the school you're trying to go to. or the national lab you're trying to go to. For national labs, definitely you have to interact with a lot more people. So depending on the position again, because there's so many positions open at national labs, it may be hyper competitive or you can get in easily.
Mm-hmm.
Universities, I think that depends more on your connections. Do you know the person you're applying to or not? Does your advisor know that person you're applying to or not?
Mm.
And then also, like, you may not be interviewed at all for a university.
Mm-hmm.
If you just casually talk to them in a conference or something, you may get the position or something like that.
Mm.
So in those university settings, I think that's you just talk with the professor and then they may include you or not in their group. For the national labs, it's much more of a commercial interview setting with 8 or 9 different groups of people. And for teaching, it's just with teaching positions, I think you go directly into the university as a teaching professor. I'm not sure, but I might need to ask about that.
Yeah. Okay.
Yeah.
So like so in terms of maybe the postdocs that you do at university versus at the national labs.
Very different.
Okay.
Yeah.
Like what are the big difference with the two?
The amount of sheer resources you get in a national lab cannot be compared to a university. So in a university, you're probably limited by the fact that you're working in one singular research group with a limited amount of resources because your advisor can't buy them all. You wish it could. But in a national lab, it's singularly focused on getting papers to the point it's almost industrial. Like you're working in a academic university setting, you're working as a, part-time, you might have to TA or something like that. And then you just do research on the side. And of course you're very busy. But when you go to a national lab, it feels like you're working in a newspaper article, magazine cover company. Because you go in, you print out papers as fast as you can, and you'll also have all the resources you possibly could want. If you ask for it, then you can probably get it, or you can get collaborators very easily because you're working with literally hundreds of people. So it's a lot faster paced, and I would say it's even busier. But that's, again, depends on where you go. But it's even busier usually than most university life postdocs. That's debatable, actually. Yeah, but I guess at the end of the day, it's just the resource that makes the big difference between university and a national lab.
Mm-hmm.
And, with more resources, you can do your work a lot faster. And they expect more.
They expect more papers, right? You have
Yeah.
to turn out like 4 or 5 papers.
Yeah, exactly.
a
They
year or
expect
something.
there's a status quo where have you published these papers? Just
That
publish
sounds
it.
crazy.
Yeah. It's going to be fun, that's for sure.
So is there a trial period where if you don't get it in the first year, then they kick you out? Or how long is the postdoc supposed to be for?
Depends on where you go. Usually postdocs will end up in 2 years. Maybe they'll sign you on for 1 extra. But beyond that, you need to find your way either into a R1 institution or a different university or a research job. Yeah.
And both the national labs and like the university could both lead you into professorship jobs or something.
Exactly.
Okay.
Or I think this is my primary motivation is that you can take the research and then put it into a research position, such as a research associate at a national lab. There's a lot of opportunities, especially in America, where you can have just primarily research, especially in the defense contract area, although you may have to work in some classified stuff and requires a citizenship, where it's primarily just R&D. I would very like to be in that part of that field, hence why I'm going in this postdoc pattern. Less so the R1 institution, but I'm keeping my tabs open. We'll see how this goes.
What is an R1 institution?
An R1, Research 1 institution is basically a group of universities that does a select amount of research production every year, such that they make it into this prestigious list of universities that is contributing to science.
Okay.
I think there's like a status quo of how many papers they produce and how many PhD students they create. And that's most of the professors that work in R1s. Their primary job is producing PhD students and also actively participating in research.
Okay.
Yeah. I think there's a list, but I don't remember what website that is.
Okay.
Yeah.
So why did you end up choosing? So you chose to go down the national lab route because you do eventually may be interested in doing more research scientists.
Exactly.
Maybe
So
go into industry, or what do you think?
less on the industry part, but more into like the scientific research,
Okay.
R&D development, and positions for like making papers and pushing the boundaries of science a little bit further. There are positions out there that doesn't require professorship to do these things. And as I understand it, it's highly competitive, so I really do need to stick my best foot forward. And it's a field that I'm not too familiar with, because there's a field for like people who work as support scientists who help you do the measurements, and then a field of scientists who mostly do research by gathering grad students and grants and stuff like that. And that's kind of like the field I want to go into, where it's just mostly just research and not really too much into professorship. But we'll see. I know a couple of research associates who became professors in the end, so who knows where the journey takes me.
Okay.
It's a bit arbitrary. I wish I had a better understanding of where I can be, but the title of research scientist is few and far in between. So it's a bit pretty rare to see a research associate with a very clear path on how to get there. But one of the ways that's helpful is definitely a postdoc. Yeah. Yeah, one thing I want to say is that a postdoc doesn't necessarily mean you're trying to be a professor. There's other options out there.
Yeah.
Plenty, actually. Including the industry. But that's not necessary for a postdoc.
Huh. Yeah, that's interesting. Yeah, I mean, I'm learning stuff here that I wasn't. Yeah, that I'm surprised that I wasn't aware of. Like, just in general, it sounds like once you get past the PhD and then once you're going into the postdoc, there's still so many more paths.
There really is, and I was surprised by that too.
Choices to make.
Yeah, it was. There's a whole another industry out there where it's just primarily for research, rather than just academia. So academia is not the only one that makes contributions to, science and stuff. There's really institutions out there that are built for that.
Yeah.
And honestly, those institutions work at just such a dramatic, fast pace that they can sometimes outpace some of the R1 institutions.
Because their main focus is just
Research.
And they have funds, right? They have tons of funds, and it's research only.
They have access to more grants, that's for certain. But I think their life is just looking for grants half the time.
Yeah.
And then publishing research the other half. It's a busy life. We'll see if I fit.
Yeah, it's interesting. So I'm curious how you're. Like, what's your sense? Like, what are you feeling going into the postdoc? Like, I heard excitement. I imagine nervousness is in there.
Definitely.
Like, I'm wondering where on the spectrum that is. Like, a little nervous. Are you shitting your pants? Like, somewhere in between.
I think the excitement beats the nervousness for sure.
Okay.
The amount of freedom you're given as a postdoc is like, they say the postdoc is the happiest part of your academic career because you don't have to worry about grants, and you have a lot of freedom in what you want to research. So this is the time when I can really satisfy my curiosity of where I want to take my path in terms of research and scientific interests. So I'm very excited to see where I can take my curiosities all the way from when I was 12 years old, right? Applying it here. This is the time to look for it. And for nervousness, oh yes, I'm very nervous. I'm in fact nervous about all those comments I made about procrastination. But it needs to be said that while maintaining a aura of professionalism going forward, that when you just start off, you don't think you have, and your confidence builds as you do it more. I think it's the main thing that should drive me in a postdoc should be enthusiasm for what I want to do and just curiosity. And then as long as I have those things, I think I'll still remain motivated to be in this subset of research and academia as well. Yeah. So it's nerve-wracking for sure. Like, do I have to maintain publicity? Do I have to be extra, like, whenever you meet postdocs, I put them on a pedestal because they seem so smart. But becoming one yourself, you have to take baby steps to get to where you need to be.
Of course. Yeah. Well,
I was going to ask along those lines too. Like, do you ever have feelings like, I guess they call it imposter syndrome, or like some doubts about like,
imposter syndrome, it's a serious problem in academia. It gets even worse in postdoc. At least I heard. And I think that's something I always will have to grapple with as long as I remain in the professional field. Right? So am I good enough? Am I trying to be someone else? Those kind of feelings. But I think the only way that I can resolve that is just by working at it. Maybe publishing those papers and getting to know the people in the profession. Talking with them, seeing how they feel about their research, and also knowing what the language of the hot topics are at the time. And I think that's what really builds the confidence. If you get into the nitty-gritty, work out like what's the culture of what you work in, and then and only then does the really imposter syndrome start to simmer down.
So like when you feel it, you just say, "Oh, I'm just gonna keep working. I'm just gonna keep learning more. I want to keep going down this route. So I'm just gonna keep."
Exactly, until it comes time to like where I have to put down my cards and show what I have. I'll just my way of going through the imposter syndrome is just being curious, being just working and understanding about what it means to be professional in academia or research, and then just gaining confidence that way. I don't think there's really other ways around it, really, other than just experience, sadly.
Well, yeah, I don't know. Actually, I might have something to contribute there. Is when you say this, it's interesting. It's like so just to reflect, like it sounds like the way that you process your imposter syndrome is you continue working, and then it seems like at some point you're hopeful. Maybe it's already happened in the past. Maybe you have some past experience where that you continue working, and then at some point you look up and you're like, "Oh, I belong here. I made it."
Sure.
Have you experienced that?
I don't think so.
Okay.
Which brings up the question, does it ever come, right?
Okay. Well, so anyways, the way I was interpreting that, I was like, oh, okay. So then sitting with that imposter syndrome, it seems like your method is kind of just being patient, like allowing that imposter syndrome to sit there and be, just having faith, or perhaps that it's gonna, with continued effort, you're going to make progress and you're going to eventually become more confident in your position, right?
When you put it like that, it does seem like a double-edged sword. Yeah.
Well, no,
but
I didn't notice whether or not it was a double-edged sword. I'm just saying that that's what I heard. And the way I've addressed it is like more trying to, I don't know whether internal is the right way to say it, but like, yeah, what am I trying to say? It's trying to like pick apart where the imposter syndrome comes from. There's like, it's like a feeling, right? So then it has a root somewhere. And so tracing it back to where does the root go, right? And so there's certain insecurities that, I might have found within myself that I can then start addressing, right? So it's like, I guess I experience anxiety, fear, a sense of like my fight or flight kicking in of like, okay, like, I'm expected to know this thing, for example, and I don't know what the hell's going on,
Right.
And I'm like, oh, I'm just a piece of shit. I don't know anything that's going on. I shouldn't be here. Someone else should have my spot. Then I go back on a journey through my mind of like, okay, well, why do I feel this way? And it's led me on a really long trajectory. That root goes really deep in my experience of like trying to do like identity work of like me uncovering who is it that I think I am, like why is it so important to me to be good at physics, for instance,
Right.
And then like unpacking that, and then like, okay, then that goes deeper of like, why is it important to be good at anything, or why does this add value to who I am, or why does it, so on and so forth. There's all these questions and all these tangential ways of like, I go to the root of what I think is myself.
Interesting.
And then I unpack that piece by piece. And then I haven't exactly completely detached, but I get to the point where it's like, the imposter syndrome is more like an echo, it's like something from my past life that like, I recognize, I used to experience a lot, and now it's like, oh, this thing is reminding me of when imposter syndrome was like so present in my life, and the signal was so loud. But now I understand more or less the roots of a lot of that stuff.
Oh, I see.
And so it hasn't fully gone away, but it has lessened, I guess I would say.
Right. I think I could have had that, but there's two things that stops me from putting my ego on my physics knowledge. First is I think of physics as a tool.
Yeah.
So all I need to is just add another socket wrench, another nugget of knowledge to kind of make me competitive. Mm-hmm. And then the second thing is my advisor was amazing and always told me to never compare myself with other people, because you have your own individual journey that you have to make your own steps, and you have to make your own trail make your own trail and new discoveries, because every individual has a contribution to make because of their individual thoughts. Yeah. So I think those two combined together kind of help mitigate in terms of I'm not good enough. I think that kind of I'm not good enough panic may come in when I need to look for new opportunities or new jobs. So the transition period is when the imposter syndrome can really kick in. When you're on the interview bench being interviewed with questions of like, oh, why'd you do this? Why do you have not enough of this? And all that other stuff. But during the time when I can work, I can kind of help resolve that by adding to the toolbox of physics, talking with other people to get a basic understanding of what they're doing, and making how I can make myself more competitive, and just building upon my career, because I'm still maybe it's the folly of youth of just starting, But I do feel that I'm not quite there where I need to be a master yet. But there are definitely paths that I can take to get there. Yeah. We'll see.
Yeah.
We'll see.
Well, you're a doctor now.
Yeah.
And you've been a master.
Yeah,
so
you're higher than a master.
You're higher than a master now.
You're a doctor.
Yeah. But there's always things to learn.
Right.
Yeah, I know.
Once you start on this path, you're always a student.
Yeah.
Yeah.
Yeah. So there's a couple things I wanted to emphasize because that totally makes sense. One, I think that's wise of your advisor to share that perspective, and I think it's sweet. I think it's sweet.
Careful when you pick your advisor. It really determines your path and how you study.
Yeah, for sure.
And then the other thing is viewing physics as a tool. I think that's important because it sounds like that provides a level of detachment of like you aren't your physics knowledge, right? Like you can always add to it. Like you're not, attached to it per se. It's just a tool, right?
Yeah.
So it's just, pick up another tool, add another tool to the tool belt, and then, it doesn't affect who you are as a person at all, right?
Yeah. It's just, I guess I shifted the importance of what I wanted away from physics to like goals and dreams, right? So that I might have a more of an emotional attachment to if I can't do it.
Okay. Could you talk on that? What are your goals and dreams?
Like try to get into the field of batteries and improve on current technologies. I want to be in the part of that field, right? And then physics will be just a tool to help me get there. And also help me like improve upon the technologies that are in here today. And if I couldn't make progress in that, I suppose I would be much more frustrated rather than I couldn't make progress in other subsets of I don't know enough physics. So it's slight detachment from physics as a subject. Yeah. But that also puts emphasis on I need to also accomplish what I want to do in progressing technology, progressing my dreams of making batteries better, spintronics better. So let's see. Yeah.
Can I ask the 4-year-old question? Why?
Why
is your goal to advance the state of battery technology, or like if you were to go to a level more general, more abstract, like what's important about that to you?
So I think this one it's near and dear to me because I grew up with the idea of like, oh, I always wanted to do this. Yeah. And I would attach some ego on that, right? Of being able to like progress in terms of battery technology. I talked with a undergrad that I worked with in my group before, and then he also had very similar dreams to mine. So what I said was, oh yeah, this is like the modern equivalent of the superhero story. You can save the world by bringing an end to climate change.
Okay.
Right. And then maybe if we just had better batteries, it'll just magically float away. It's probably not that simple, but it's I think it's a prevailing thought that is shared by a good portion of other people. That it's a dream. Yeah, it's one thing you can pursue, and it really helps that the dream's so concrete. And I would absolutely love to be part of that process. As for why I do it, it's still that childlike motivation to be maybe like the hero who saves everything, but also just curiosity about exploring the things around me, playing with Legos, making new stuff, having a little bit of fun on the side.
Yeah, that's great. So, unrelated, you still play with Legos?
I do not, sadly.
Oh, okay.
Yeah, it's unfortunate, but the Lego life is behind me at the moment. I wish I would.
Yeah, I don't know if you want me to share this, but Irene has just been getting into Legos, like
the sets.
Yeah, had her first experience more or less.
Oh my goodness.
right?
Yeah, I had my first experience with the Lego sets, and it's fun.
Did you?
But I haven't made anything myself, like original.
Is it like free building, or is it like a set that you have to like?
It's a set.
Like building a flower or something.
Yeah, something like that.
Mm-hmm.
But
Yeah,
I haven't gone into free building yet.
It's definitely more like for. I think it's more for children. I'm not sure if that's true. Now I might be insulting a wild plethora of people
there's
every
a
audience
whole
here.
Lego art installation.
Oh yeah, we did see that.
Yeah,
that
those
he
are
makes
cool.
at Lego
For sure.
art,
Yeah. When you like build like physical, it's almost like making a painting almost.
Yeah, it makes paintings with it and everything.
Yeah. So when you were a kid, you were free playing, or did you use sets at the time?
Free playing.
Yeah.
You know, toddler stuff.
Yeah. Okay.
Yeah.
Mhm.
Making a construction, chucking it off of the stairs, watching it explode. Probably shouldn't do that, kids.
Yeah.
Well, I mean, I guess I wanted to know, what would your 12-year-old Simon think about what you're doing now?
I don't think I'm that different now. Same curiosities, same amount of, dare I say, ignorance. Just mild understanding of quantum mechanics, mild understanding of physics.
Mm-hmm.
Mindset-wise, it hasn't really changed all that much, I'd say. So I guess my 12-year-old say, what's different here?
Mm-hmm.
Who knows? Maybe he'll be proud.
I'm sure he'd be very proud.
Oh,
Yeah.
let's see.
Yeah.
Got a PhD in physics. What are you doing?
Yeah. Not many people end up with those two letters.
It's like, how'd you get here? Yeah.
Yeah. Well, I'm mindful of the time. I'll open it up to the floor. Is there anything that that you wanted to chat about that's like lingering in the back of your mind that you're curious about? Or Irene, if you had any other questions?
Let's see. PhD experience, huh? Looking back on it, I don't know like how to comment on that. It just felt like a fever dream almost.
A fever dream?
Did it happen?
No, I just meant if you had any questions about anything. If you had any questions for us, or you found something from a conversation you wanted to talk about more, or anything like that.
I can't really think of anything. Gosh.
That's okay.
A bit empty-handed.
Well, what was, like, I guess, if you had to say, what was something major you learned, I guess, throughout the PhD? About yourself, or about life, or did you refine the philosophy of life? Or?
Other than quantum mechanics?
I guess I just learned to take things a little bit slower, which is counterintuitive to what I should be as a scientist. I guess that's just like being patient with the little steps you have. Because when starting off, I was panicked. I was trying to do everything quickly, and try to keep up with the modern scientists or whatever who are years ahead in experience. It doesn't come in a day. It stacks up. So just learning to be a little bit more patient with every step I take, every textbook that I read and notes I don't take. And yeah, that's really it. It's a long journey, and I've been told once in my undergrad experience that as a undergrad you learn basic physics. As a grad student, you learn what you don't know. And then as a postdoc, you finally build a basic grasp of everything you need to know in physics. And the professor is when you begin to pursue your interests. And at full professorship, you finally become the master. So it's a very long journey ahead in academia. It's words of the wise, but it's also very pessimistic about what you come out as a PhD student.
Yeah.
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 Yeah, it's like, wow, you're just starting.
Very hardcore.
Yeah, and that reminded me of something I wanted to share a while ago. Is you're talking about being nervous about your procrastination habit. What I wanted to say at the time was that obviously your procrastination habit isn't that bad if you finish the PhD.
Apparently.
It's
I barely got by, but yeah.
Yeah, but you got by, right?
Yeah.
It's workable enough that you could do what most of human society can't do, right? So, your skills are definitely at a level that maybe you don't need to hear this because you're trying to change the behavior, but I'm saying that, maybe you could deserve it to
cut some slack.
Yeah.
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 We'll see how this goes. Either way, I'm excited.
Yeah. Good.
Yeah, I'm glad because I don't know about you, but I feel like motivation has been lacking in the culture, in the grad student life, and I kind of wish that would change. I feel like I'm lucky enough to be like motivated throughout the PhD, and I'm sure many people are, but burnout is kind of like something that was kind of sad to see. And
in others, you mean?
Yeah,
or in yourself?
In others. For me, it didn't happen too much, if at all. Maybe the last couple days of like all-nighters every 2 days was bringing me closer to burnout. But I can safely say that maybe the procrastination helped. But with the amount of pace that I went through, burnout wasn't really too much of a hassle that I had to deal with. And that was good.
Yeah.
Yeah, I definitely have had cycles of burnout, and then
Where you just can't get out of bed and don't want to work.
Yeah, I can't do anything, and
That's
then
like
I have
severe burnout.
and then I have to take. I just have to take
Take
time
the day off. Yeah.
I'm saying weeks off.
Weeks. Yeah.
to recuperate,
I
and
don't
then
think
I
I
get
ever had
out.
that.
Then I can get out of it again.
Yeah. No. Procrastinate more.
I procrastinate a lot too.
Yeah. You should talk. I mean, she didn't share, but she's a master procrastinator.
A master. Yes.
Yeah.
We all are.
I don't know. I mean, my whole life has been just a big procrastination. So.
Yeah, I could tell you some of the stories. It's pretty fascinating to watch. I mean, it's impressive, honestly. Like, because it's like, you're talking about for yourself. Is it okay that I'm talking about
Yeah,
that? Okay. Just want to make sure. So you're talking about yourself. It sounds like you get an internal sense of like, okay, I have this long to like, is like the absolute last moment or whatever that I could start taking it seriously, and I have to start pulling all-nighters and stuff like that, right?
Yeah, I set ridiculous deadlines for myself that are way too ambitious and always will be late.
Yeah, and that's
the only way I can possibly do it.
I would say that I think Irene works in a similar way.
I work similarly.
It's just like it's in a way that the deadline to me seems impossible.
Yeah,
and then a lot of times it is late, but somehow it just works out.
Yeah, exactly.
It's just like
with the presentations, right?
Yeah.
Too. With presentations, I'm sure.
YouTube, annual review, prospectus, QFT.
Do it all last minute. No, that never changed. In fact, if I go to the postdocs right now, I'll be like, "Hey, when do you do your presentation?" It's like, "Oh, it's not done yet." Yeah, people leave it to the last minute, and we need these deadlines to actually do it, and then get it somewhat close to completion. So at the very end, we have like a presentable format. But yeah, we'll see how this goes. Oof. Ooh, now I'm nervous.
Uh-oh.
Okay.
That wasn't the intention of the podcast.
No, it's okay.
Yeah, I should have not shared that bit.
No, I'm just joking around.
But
well, I was gonna say if there's one, it's just an overarching question, because we watched The Bear recently, and they asked this question. I wanted to ask it to you, like, what would be the legacy that you would want to leave?
For who?
So the context of the show was
maybe you give context.
It was relating to like a family member's death or something, and then two characters were talking to each other, and they were just talking about they were looking at old photos of this guy who went to like work at these really fancy restaurants and stuff like that, and work with these incredible people, and then he's talking about legacy and about how the progression of cooking of dishes, of how it passes from one
to the next. Right?
Yeah, and how food is kind of like a legacy at these restaurants of like, this dish gets passed on, and then you teach their chefs and whatever. Anyways, so then they started talking about like, what would you want your legacy to be like after you were gone or something like that. Like what impact would you hope to leave on the world?
I don't care too much about physics in that perspective.
It doesn't have to be about physics. Yeah.
I think I'm just happier just like talking with people and chatting them up. If I could just like have a good memory with them, that's enough for me. In terms of what I can leave with other people, is just having a good time, really. I don't know. It's like if I had a kid, then that would have some context to it, passing on values. But that's certainly not the case for me at the moment.
Mm-hmm.
Yeah. In terms of just friends and people I meet, I think if I could just, learn about different stories, different lives, and different things, that's enough for me. Leaving something behind, I guess that's something I have to think about during midlife crisis years. We'll see how this goes.
You haven't had your quarter life crisis yet?
Oh, I'm well into it. Thank you.
Okay.
Have you?
Yeah.
25s and over, right?
Well, have you had the actual crisis?
Where you feel
Probably.
where you feel like, what the hell am I doing? Like in the PhD, you ever feel like, what the hell am I doing here? Why am I doing this? Is crazy. I should just go leave and get a normal job like all these other people are like.
No.
Feeling totally lost.
No. I think for the dream bit, it was all or nothing. And might as well do this and have some kind of motivation in life.
So you have your dream pulls you towards it.
It's
you just work for it.
It really does simplify your life, but it's not for everyone because you have to make sacrifices.
Well, everyone works differently too.
Exactly.
So, their mind works different.
Yeah, no. Just having a goal like that, even though it's like imaginary and probably fictional, keeps you on the straight and narrow, I'd say. Yeah.
I mean, it gives you something to work towards.
Exactly.
Working can help you.
Midlife crisis, of course, you think about, I could have gone a different direction, but then I think like, I'm not sure if it's going to be better than what I want to do right now. So it's like, it's not too bad. Yeah.
So you're feeling pretty content with your journey so far?
Right now, I'm where I want to be. That's definitely for sure. We'll see you out at the end of the postdoc.
We'll
Reevaluate
check
yourself.
in again with you after the postdoc.
Yeah.
Oh no, what have I done? Who knows? It'll be exciting. Exciting times ahead.
Yeah, well, that's incredible.
Yeah, it really is incredible.
Yeah.
Well, I'm proud of you for, finishing this up and moving on to this next part of your journey. I think that's incredible. Is there one last pass of the ball? You feel content with that last question?
Yeah.
All right. You feeling okay? Good?
Yeah. Good luck to everybody, to whatever they're doing in life.
Well, thanks so much for coming on the show. It's been a pleasure. And we'll sign off of the podcast now. Thanks for listening, everyone. Catch you on the next one.
Thank you so much.
Thank you.
All right.